All right, let's dive in. Today, we're putting on our detective hats because we're going on a high-tech hunt for a hidden culprit, one that slows down our world in ways you probably never even thought about. And our investigation? Well, it all starts with a single question.
Seriously, think about it for a second. You've got cars stuck on a highway, a production line churning out widgets, and data zipping through your phone. What on earth could possibly link all three of those things together? It sounds kind of like a riddle, right? But the answer is this super important concept that messes with just about every complex system out there.
Yup, that's it, the bottleneck. It's like the ghost in the machine, this invisible wall that just caps our speed, our efficiency, and our progress. So in this explainer, we're going to figure out exactly how you hunt this thing down. To really get a handle on our target, we have to start where the evidence is just piled up, the production crime scene. This is where bottlenecks leave their most expensive fingerprints, for sure.
So, what is a bottleneck really? Well, the name kind of gives it away. Just picture pouring water out of a bottle. It doesn't matter how huge that bottle is, the water can only come out as fast as that little narrow neck will let it. It's the same thing in any system, whether it's manufacturing stuff or just sending an email. The bottleneck is that one single part of the process that puts a speed limit on everything else.
And make no mistake, this is not a victimless crime. When a bottleneck gets ignored, the consequences are, well, they're bad. We're talking angry customers tapping their feet waiting for late orders. We're talking budgets that completely spiral out of control. Entire factories are just not producing what they could be. It's a direct shot to efficiency, and it really hits the bottom line.
Okay, so how do modern-day detectives actually find these sneaky culprits? Well, their methods have gotten incredibly sophisticated. We've moved way beyond just, standing there with a clipboard and watching.
See, back in the day, you'd use something called static analysis. You'd basically look at the system on paper, kind of like a single photograph, and you'd guess where the problem might be. But the real world is messy. The actual bottleneck might change depending on the time of day. That's why today, the absolute gold standard is dynamic analysis. It's like watching a nonstop movie of the system, so you can see problems pop up as they actually happen, in real time.
And the tools they use to watch that movie? Honestly, it's straight out of science fiction. We're talking about AI that actually learns how the system behaves, cloud simulations that can build a digital twin of an entire factory, and even large language models that can read through engineers' notes to find problems. This isn't just guesswork anymore. It is some seriously high-level data science. So how does all that fancy tech come together? Well, take a look at this method, the zero-based framework. It's so clever. First, you just grab all the real-time data you can. Then, you use a simulation to create this perfect, fantasy version of your workflow. No bottlenecks allowed. And finally, you just compare the messy real world to your perfect model. Those differences, those little gaps, they point you right to the culprit.
But here's the part that is just a total game changer. We're moving beyond just finding bottlenecks. We're starting to predict them. Using these powerful AI tools, engineers can now look at all the past data, calculate the odds, and see where the next slowdown is going to be, and then fix it before it even happens. How cool is that?
Okay, so you've used your futuristic detective kit, you've identified the bad guy, the hunt is over. Now what? How do you actually crack the case and solve the problem for good?
Well, the solutions are just as varied as the problems themselves. Sometimes it's pretty simple. You just add another machine to do the same job. But other times it's about working smarter, optimizing schedules or using lean manufacturing ideas to cut out every last bit of waste. It could even mean improving the big picture planning with specialized software. There's a whole toolbox of fixes, from the dead simple to the super complex.
And it gets even more advanced. Get this. Some systems now use blockchain for super secure supply chain records, or they use something called fuzzy logic, which is a type of AI that helps a system make smart, human-like guesses when it doesn't have all the information. This lets a factory automatically adjust on the fly if, say, a shipment is late. It just reroutes things to avoid a total shutdown.
Now here's what's so wild. Once you learn how to spot bottlenecks inside a factory, you start seeing them everywhere. This whole idea goes way beyond just manufacturing.
You see them in our massive global supply chains. A single backed-up port can act like a clog in the world's artery, delaying container ships for weeks and causing ripple effects we end up feeling months later at the store. We've all felt this one. You see them on the highway every single day, right? That one merge point or a fender bender that creates miles and miles of traffic. That's a bottleneck. They're even in the way we walk around.
Yep, researchers actually study how a narrow doorway or a crowded street corner creates a bottleneck for pedestrians, which can affect everything from your commute time to public safety.
And this is a big one. Bottlenecks can seriously hold back progress. Our switch to green energy, for example, often isn't limited by a lack of good ideas. It's limited by manufacturing bottlenecks that slow down how many solar panels or wind turbines we can actually build.
And check this one out, because it's a bit of a curveball. A bottleneck isn't always a machine. In the clothing industry, if workers keep getting moved from task to task, their skills can actually fade a little, and that skill degradation can become the main thing slowing down the whole operation. It just goes to show you, sometimes the bottleneck is human.
So, after this whole deep dive into slowdowns and congestion and all this high-tech detective work, what's the one big thing we should all take away from this?
It's this: the job is never actually done. As soon as you solve one bottleneck, all you're really doing is revealing the next slowest part of the chain. In a world that's constantly changing, hunting for these hidden culprits has to be this endless cycle of find it, fix it, repeat. The detective's case is never really truly closed.
And that leaves us with one last, kinda huge question to chew on. As our technology and our supply chains and, well, our whole world just gets more and more tangled up and complex, are we accidentally building more of these hidden choke points? Are we creating new bottlenecks even faster than our amazing new tools can find and solve them? Something to think about. Thanks for tuning in.